Every time I hear her, I'm just so completely taken over by what is out there. So a couple of questions, Priyamvada. You talked about James Webb. So just give us a sense of all of this image that's coming is not what the universe is today.
Absolutely. So yes, so one of the odd things is that when you look out into the night sky and you look out into the universe, it's actually a time machine. You're looking back in time. Because it takes, although the speed of light is quite large, it takes a finite amount of time for light to reach us from any cosmic distance. So the nearest star to us is 4.24 light years away. So the light that you're seeing from Alpha Centauri left that star 4.24 years ago. And so the light that we see from the sun when we go out and during the day, it actually takes 8 minutes. So you're seeing the sun as it was 8 minutes ago. I mean, of course, it's continuously shining, right? But if the sun turns off, we will not know for 8 minutes. But remember, the sun is our closest star. Anything beyond, so the galaxies that I'm showing you, those little galaxies I said James Webb is finding, those galaxies, light left those galaxies 11 billion years ago, when the universe was really, we have no idea what that galaxy looks like today. We just know what it looked like. And so we see the infant universe, and we just get snapshots. We get snapshots of the universe at various ages. And people like me are building the storyline, because there is no way to circumvent this. But this is just fascinating, that we are seeing the universe as it was. We will never see anything distant as is.
And of course, everybody wants to know, so is there life outside of the Earth?
I see no reason to believe that there shouldn't be life, right? I mean, you just started off by saying, right, by reminding us that there are more planets in the universe than there are stars. And because, every star, like the solar system, there are multiple planets, right? And there's no reason to believe that there shouldn't be life elsewhere. However, I want to caution people before they get carried away, is that, life, we have one instantiation of life forms on our planet. And already Stephen Jay Gould told us, right, if you turn back the wheel of evolution on Earth and you rerun it again, there's such a element of randomness that is part of evolution of life and biological life on our planet, that if you run it back and run it forward again, we may not end up with humans that look like us, right? So we should move away from the sort of anthropomorphic fixation that there will be life like us and they will just happen to be more intelligent or evolved. It could be anything. I mean, we have no idea. So, I mean, it's exciting. And a lot of my colleagues think it's kind of scary, but I don't think it's scary. I mean, I think that I'd be thrilled to have some evidence of life.
But you said that there is now new evidence that they could possibly be.
So there, in a recent web, so the Holy Grail has been organic molecules, because we know the assemblage of things and conditions that were probably instrumental in creating life as we know it on our planet. And so we know that complex hydrocarbons, sulfur, there are many elements, and water, of course. And so they've recently discovered on one exoplanet, so a planet around another star, that has all these elements. But this is just from the spectrum of the light that is coming from the planet. We've not mapped the surface of the planet, so we don't know what's really going on there. I mean, we see methane. So it remains to be seen what kinds of life might be possible. But I think the chemical constituents that you might need seem to be available at other places. So we're not all that unique after all.
And any chance, did you guys find God out there? I mean,
I think they're still looking, but I think they don't have a good photograph, so they don't know what, the likeness is kind of a little hard. Maybe we'll need AI to do that one, you know.
Tell us, Priyamvada, a little bit about James Webb. It's really transformed the way that we're seeing the world. But this, again, was a dream project for James Webb. And how did that come about? And what was the vision and the dream of that? And more importantly, how have you got involved in it?
Yeah. So I'm not officially involved in the, I was not part of the engineering team or in developing a web, right? It's been a 35-year-old saga, and this project got almost canceled multiple times. The reason this project was unique is that it accesses the mid, far, and near infrared. So this is a part of the electromagnetic spectrum. So as you all know, light, we can think of it as waves spread over a range of wavelengths. And these are very sort of long wavelengths, reddish wavelengths. So the wavelengths are longer as you go redder, low energy, but these can cut through the dust. They scatter off the dust. And the early universe is filled with dust. We know that. And therefore, the infrared radiation is the only one that can escape. And we didn't have detectors before James Webb that were sensitive to this portion of the spectrum, right? And we've had X-ray detectors for a very long time. So we've been seeing energetic phenomena from the universe. We've never seen this. So this was a new window that people really wanted to open up. But then, on the other hand, there was a trade-off. Not only did you need these detectors that were sensitive, you also needed a fairly large mirror. And the question is, given our current capabilities to launch stuff, as you all know, many of us, astrophysicists and astronomers were on tenterhooks that Christmas when they were launching, right? Because this whole thing had to open, unfold like an umbrella, and with nanometer precision. And they were well over 300 single-point failure possibilities, right? Because it's a complex machine. So it really is a miracle, and it's a long-awaited miracle. And we knew already that our picture of the universe was incomplete without these wavelengths. You have to see the universe through these multiple windows, and then we have to put it together to understand fully what's going on.
And the life of James Webb? How long will it continue to feed us?
So I think that the launch was just so efficient that we believe that 5, 10. I don't want to jinx it, but it's going to be up there for a very long time. And I think for me, I actually came into astronomy when Hubble was launched, and that was a dramatic revolution because it was the highest resolution images, and it was Hubble that opened up this field of gravitational lensing. You could not see faint enough things to catch all the mangled shapes and so on before that. So, my entire career, I have benefited greatly from Hubble, and now so that's all the dark matter work, and now it's the black holes that James Webb is revealing. In between, of course, we've had Chandra, the X-ray space telescope, that was revealing all the growing black holes. So you were not seeing the ones that were, the piddly feeders, you were not seeing them, but you were seeing the energetic ones. And I think what for me has been personally just like sweet is that this quasar, this most distant quasar that we actually discovered, it turns out we discovered it because it was behind a lens, and it's a lens that I have modeled before. So I really felt that these two interests, in the profession, our profession is very specialized. And so a lot of people told me when I was younger, well, don't work on these two huge problems. There are two huge problems. Why don't you pick one and become, the world's expert in this? And I'm like, well, I think I can do both things and become an expert. And even my advisor, he cautioned me, he said, well, Priya, you may not get credit because, your work will be diluted across two problems. They wouldn't know whether you did this or that, or, I did what I wanted, right? And it turns out in the end, these two fields have actually converged, and it turns out that the easiest way to find distant objects, so distant objects really test our understanding because, you build a model and everything for the distant universe is an extrapolation, and that will be tested only when you have data, right? So it turns out the way the universe works, like the most distant objects will almost always be found only if they are lensed. So I ended up, picking sort of these two areas that are actually sort of beautifully married to each other in terms of the physics of what they can produce that we can see.
One of the things, the popular conception is that the black hole swallows, and the black hole is a place of great destruction. But again, you all have been extrapolating that in this destruction also there is creation of new stars.
Right. So you actually don't create new stars right around the edge of the black hole, but you create stars out of gas. So you have all these gas flows, turbulent gas flows that are around black holes. And since black holes most black holes sit at the centers of galaxies, you have a lot of star formation in the inner regions. And so we believe there's an intimate connection between the feeding of black holes and the formation of stars. So that is one of the frontier subjects that we are trying to work and uncover. What is the nature of that connection, aside from the obvious one that both of them involve gas, right?
And is the puncher in space that you showed us?
I can kind of guess where he's going.
Yeah,
I know where he's going.
Is that something that will let us out into is that interstellar? Is that sort of...
That's the concept they ran with in Interstellar, right? Which is that is meant, a puncture is meant to be what we call the wormhole, take you to a wormhole. And because this is puncturing the space-time of our universe, we believe that the place that it leads to has to be another universe. It can't be another location in our own universe. It has to be somewhere else. And so that's sort of where, I'm a great Nolan fan, so I love that film. And one of my friends, very famous physicist Kip Thorne, was involved very much in the making of that film. And to this day, he says that his only job was to really make sure that no laws of physics were violated in the depiction in that film, because he wanted to be really faithful to the laws of physics. Yeah.
And the last question to you, what got you so interested in physics and astrophysics and everything that you've been doing?
Yeah, I guess first I have to mention, I recently lost my dad last month. When I was a kid, he bought me a telescope and a microscope. It was pretty clear to me which one I preferred. And also, I was just very lucky. I was very fortunate that, I was born into a privilege, into a highly educated family, academic family. And so I had a Commodore 64. Those of you who are roughly my age, which I will not reveal, will know. I mean, I had a computer in India before any institution, school, anybody had one, and I'd learned to program. And so, I just got a head start into science. I was a curious child, and I just read a lot because I happened to be born in a house with lots of books. And I had a facility for mathematics, and I just loved physics. But I was torn because I loved literature and history, and I loved to write. And I somehow thought at that time, as a young person, that these were sort of two things you couldn't simultaneously be. I had sort of bought into this two-culture thing. But as I have grown older, I've realized that that's such an artificial boundary between the sort of humanities and the sciences. It's all creative work. It just involves a slightly different lexicon, what you do it with. And I feel super grateful to be able to do what I wouldn't. There are moments, I have friends who are titans in the IT industry, because I am that generation of MIT graduates, the people who started Silicon Valley. And they often ask me, right, would you have done what we've done and started companies and sold them for, astronomical number of zeros? And I said, no, I prefer the astronomical number of zeros that I'm dealing with. Anyway.
Ladies and gentlemen, Priyamvada Natarajan. Priyamvada, we look forward to welcoming you back once you get your Nobel laureate. Congratulations, and thank you all. I'm sorry we didn't have time for questions. Priyamvada Natarajan.
We don't have time.